So now that we've talked a little bit about some of the slots on our motherboard and what our motherboard does, we need to know how it communicates back and forth on our computer. The information pathways that are on our motherboard, the path which information passes through, are called buses. And a bus is a communication channel for our motherboard. Now, when we think of a communication bus, we want to sort of think of a highway. Specifically, how many lanes we have on our highway. When we have a split highway with one lane on either side, we can only get, say, in this 1 mile stretch of highway, we can only fit 10 cars in each lane at a time. So at total, we have 20 cars per mile of highway. Well, that's sort of the way that the bus works. A computer bus, sending that information back and forth, can only handle a certain amount of information at one time. Now, the amount of information it can handle, its width per se, can either be, in this case, 32, or in our desktop case, we have 32-bit and 42-bit, or 64-bit, my apologies, 32-bit and 64-bit. The difference between the two would be like having a 2-lane highway versus having a 4-lane highway. You could definitely tell that we're going to get more cars through, we're going to get more information on our 64-bit highway than on our 32-bit highway. On our computer, we generally have 3 typical buses. We have our address bus, our data bus, and our expansion bus. These each transmit different types of information. Our address bus transmits memory addresses between our CPU and our RAM. And then we also have our data bus, which transmits data between our CPU and our RAM. And we have our expansion bus, which our add-on adapter cards connect to. These 3 buses are going to be the typical buses on our computer, and they're the information pathways which with our computers connect. Now, we talked about how our buses have width, which are the 32-bit versus the 64-bit, but they also have speed, and the speed is the posted limits on these highways. Now, the speed of buses on computers are actually measured in megahertz, which are 1 million cycles per second on the computer. So however many cycles information can pass through these per second on a computer. As we can see on a 32-bit bus, if we have the same, say, we're going to go with 300 megahertz on both, you're going to get more information through on the 64-bit bus. But if we have a higher megahertz rating going across that 32-bit bus, if it's high enough, we'll actually get more information across the 32 bits rather than the 64-bit. It really plays together, the width of the highway as well as the speed limit on the highway, how much information is going to get through. To do a quick visualization of how the buses work on our motherboard, let's just draw it out real quick. So we have our CPU, which is our central processing unit, the brain of our computer. It's running the calculations, it's making the logical, doing the math essentially on our computer, doing the logical evaluations. We're going to have our address and our data bus, which are going to go down to our memory. They're going to pass information back and forth, our memory addresses and also our memory data. That way, while the computer is making those logical decisions, it can store temporary information in the memory. And then we have our 3rd bus, which is our expansion bus. And that will go out to our input-output ports and our expansion cards and allow our computer to talk to our peripheral components. So using those 3 buses, or 3 basic buses, our computer can get information in, send that information to the CPU to start calculating. The CPU will push that information onto the memory so it can store it while it's thinking of additional equations processing. And then the CPU and the memory talk back and forth until the CPU has an output and again wants to send back to our PCI slots or our output, which will then again display on our screen.